Hi guys, welcome to our channel. So in today's session, which is the third part of visualization, we'll be exploring some of the bivariate analysis or bivariate plots between continuous and categorical columns, as well as categorical with categorical columns. Okay, so in the previous video, we got a hint of the bivariate analysis of continuous with continuous. We also did bar plots, which consisted of exploring a continuous column with respect to a categorical column, right? So today we'll be doing a little bit of more on that, but using different plot apart from the bar plots. So let's first import all the necessary libraries. Let's read the data set first. So after doing this, what we can do here is I will simply do df is equal to df dot drop id x is equal to. So we'll have all these columns just like before in the previous video. Now what I'm going to do is we'll do a quick recap of what we did in the previous video, right? What we did, we had, so this is the code of the previous video. So we had created a function which gave us the bar plots, right? Correct? For a categorical column with respect to a continuous column. Same can be done using box plot. Okay, so today we'll be doing again continuous with categorical, but with box plot. Okay. So in the same function itself, we can do both bar plot and box plot. I'll simply have to change the function, say plot bar, comma, underscore box plots. Okay. And here we can have a type which says my typical type underscore I have to put because type is already a function in Python. Type underscore, let's say by default, it is bar. And if it is not, then we'll have to put it as box plot. So what I can do here, I can simply have one more if statement here. If type underscore equal to bar, then I'll have everything else as this, else I'll put SNS dot box plot, right? X equal to object, Y is equal to I, same syntax. Let's see if this works. Now I'll simply use this entire function, but 1 second, I do not know what is con calls. So here also, I could have repeated this entire code in the previous code, but I still create in separate code so it becomes easier for you to understand, because I'll be uploading all these codes in GitHub, along with the names of the, so the same names as the video title. So it'll be easier for you to correlate. Okay, so what are con calls? Nothing but con calls are those columns which are float. And my object column is equal to species. Once I do this, this should be dot index dot to list, because I need a list of the columns, right? Okay, so once I have this, okay, this should be object. Okay, because by type I have put as bar. Now, if I do it as box, watch what happens. And if it is default, I don't need to. By default, it'll give me the mean. I don't need to put anything here. And this, I did not put it here. I can simply put it as type is equal to box. Right? So now I get a box plot of the entire observations. Okay. The 50 percentile is given by the median line, right? And if I want to compare it with the bar, it's same thing. See, it's 5. Median is almost same. So 5 point something, 5 point, I think it was 5.9 or something, then 6.5, 5.9 and 6.5. So this is 5.9. You can see here for sepal length, this was 5, nearing 5, slightly more than 5. And this was around 5.9, which is correct. And then we have this as 6.5. But along with the median, my box plot will give the distribution of my entire data. Now, if I reverse that, let's say I'll use the same function again. Okay, or what you can do here is, suppose let's say I'll use this particular for this particular diagram. Okay, SNS dot box plot. So box plot is a function which can be used for both univariate and bivariate analysis. If you remember, if I simply do df of, let's say, sepal length, right? Sepal length centimeter. Okay, sepal length centimeter. If I simply do this, I'll get this figure, right? But if I make an effort to segregate it with respect to the species which I have, all I have to do is this. So I have to put specified data is equal to. So same box plot can be used for a bivariate analysis like this, where we have the individual distributions or box plots of sepal length with respect to the different categories of species. So the entire box plot got segregated based on the species. Now, if I make this as Y and this is X, same thing I'll get, right? Now, can I evaluate this with respect to the pair plot which I had? So let's see. So SNS dot, or let's say distribution plot, I can simply put a distribution plot, right? Say dist plot. If I do, does it have hue? Okay, it does not have hue. Now, can I check this with respect to the distribution plot which I had for the various categories, which was easily achievable using the pair plot, right? But what if I want to plot the individual distribution plot of only sepal length, only one column, and segregate it based on the different categories, right? So what will I do? I'll do something like this. So let's say SNS.dist plot, it does not have, the problem is this plot does not have the hue argument. Earlier it used to have, now they have removed it. So what else can I do? Dist plot can be used to superimpose. So if I use multiple dist plots, it will superimposed on the previous distribution plots, which works for me, right? So what I'll do here is I'll try to find out the arrays. So this is the argument of this plot, df of the column name. I need the array basically. So I'll need to find out array of sepal length with respect to all the categories. How do I do that? So I have to extract all the arrays separately. Okay. Let's say for I in, what are the categories? So df of species dot unique. This will be capital S dot do list. This is my list, and I'll say this is the species list. Next, what I'll do for I in species underscore list, say array is equal to df of species equal to I, and I can simply do SNS dot dist plot of ARR. Let's see if this works. Oh, this is wrong. I have to also specify which column I want. I want sepal length CM. I think without values, because this will give me what you call as a series. Let's see what is the issue. Sepal length CM is the issue, which means that my spelling is wrong. See, got it? Now what I'll do is I'll use a plt.figure size here, okay? Because I think it's because of the RC params, it tries to universally change it. So figure of fixed size, let me put it as say 6 plus 6. Or it is plotted separate figures. So what I'll do, I'll put it above. Certain things we'll not remember, guys. Please understand, right? Now in the same graph. So when you put it inside the list, it will plot 3 different figures. So you put it outside the list. Visualization has got a huge amount of syntaxes, guys. You don't need to keep into memory each and every syntax. You have to play around with it. Depending on the problem set which you're solving, you have to do some research and understand. Then you'll slowly remember all the syntaxes. most of the syntaxes, at least. So now if I want to compare with this was of size, I think 20 cross something. So here also what I'll do 8,6, right? Okay. So now if you look at these two figures, now watch very carefully, guys. I'll again bring this figure below so I can directly compare. How do we compare a box plot? I've already shown this to you, but let's again do that. I reduce the size a bit so that we can compare. Now, if you look at this, the blue line, which is of iris setosa, the range is small because we saw that iris setosa has lower values of all the lengths and the width of sepal and petal as well. Whereas the next in line is versical and finally virginica, right? And you can correlate the box with the distribution. So there's a huge overlap between versicolor and virginica because virginica although seems to be on a higher side, but yes, they share some kind of similar properties. Even the box size is very similar. Whereas in your setosa is slightly different because the box size is very different. The range is very different. The peak size is also very different than the rest. Correct. So all these basically talk about different characteristics of the different species of one particular attribute, which is sepal length. So you can see how both these figures are giving you, helpful information. One graph is basically supporting the insights which you are drawing from the other graph. And that is what visualization is all about, guys. Okay, so let's get back to the code again. So now we understood how to do distribution plot with different categories, like respect different categories. We did not have the hue option here, just like we had it in pair plot or box plot, but in distribution plot, we don't have that option. So I had to use a loop. So, okay, guys, that is all for today. I hope you enjoyed today's session. So we have, so the next part which is left is for us to do, categorical with categorical. So this is all in, continuous with bar plot, bivariate analysis. Yes, there are other plots which you also can evaluate, and we'll slowly do that as we do more and more case studies. Here, the first 3-4 chapters will be just learning the basics. And from the 5th session or 4th session onwards, we'll do proper case studies. So let's end the session here today, guys. So the last part which is left is bivariate analysis, categorical with categorical. After that, we'll try to evaluate some more functionalities which is used for multivariate analysis. So now, guys, there is one more thing which I wanted to add. In each of these functions, box plot, distribution, there are other hyperparameters which you can tweak, to change the aesthetics of the figure. Like suppose for distribution plot, you can simply dot an outline instead of the histogram. You can shade it, you can make it transparent, you can change the color. So all these things are for you to explore because the documentations are already there in Google. That is what Python is very handy. It has a very strong community support. But my motive is for you to understand the concepts behind all these figures. And the next session will be, on bar plot with bar plot, which is going to be very interesting. We'll use a different data set to explore that since we have only one categorical column here. If you have liked today's sessions, please like, share, and subscribe. See you in the next video.